Another important concept we should understand is the out-of-order execution. The Intel CPUs are built in a way that it has an execution engine built from several execution units, meaning each execution unit can run its own operation. Sometimes, when possible, these operations can be run in parallel. Let's take two examples. First example is very simple, assigning two values into two integers. In this case, assigning 15 into x and 16 into y. Of course, we see no reason why not doing it in parallel and gain better latency here. The second example is a little bit more complicated. We take a value from memory. In this case, we have an array, and for example, index 5, we read this from memory and put it into x, and then take the value of x and put it into an integer y. At first glance, it looks like this cannot be done in parallel, as we need the value of x in order to put it into y. But it turns out that all execution units share a common data bus, and when we are reading from memory in order to put it to integer x, this second execution unit can listen on this bus, and when it sees the answer, it can already put the value into y. And so while waiting for the memory to arrive, both execution units listen on the common data bus, and when the data arrives, they put it into the integer, and so this is done in parallel as well. Now let's go back and try to remember what Meltdown attack is all about. The Meltdown attack is trying to read a memory address where we should not have access to, and by this steal information, which can be some secret or password or whatever that we want to steal from the victim PC. And this is done by accessing a memory which is mapped into the process that we run. And how can this be? In all major operating systems like Windows, OS X, and Linux, the virtual address space of each process actually contains the kernel virtual address space in the high addresses. This is done by the operating systems, assuming that there is a protection by hardware that disallows the user mode code from accessing any of the kernel virtual address space. There is a recommendation by the hardware, the CPU manufacturer, which is Intel in this case, that says all address spaces can contain the kernel virtual address space, and it will not be able to be read because there is a hardware protection, a hardware bit on each virtual address that says if it belongs to the kernel or belongs to the user. And if we run a user mode, we cannot access the kernel virtual address space. The Meltdown attack is trying to melt down this protection, and this is where it got its name, the Meltdown, and accessing the kernel virtual address space from the user mode. This is the dangerous thing about the Meltdown. It is a very dangerous attack because it can run a simple user mode code without any privilege and get data from the most privileged memory places of the kernel, and get everything that is written into the memory. Now, we need to remember that, again, in all major operating systems, the kernel virtual address space is mapping the whole physical memory, which means each process of these operating systems is holding the whole kernel virtual address space, which is holding the whole physical memory.